Hi guys, welcome back. So now we'll be looking at another question on hypothesis testing, which deals with when the population variance is unknown. Now, a midwife claims that the weight of babies delivered at a maternity clinic is 3.5 kg. A statistician who wishes to test whether or not this assertion is true takes a sample of 10 babies, that's our N, and obtains the following weights: 2.8, 2.5, 3.2, 3.5, 3.7, 2.7, 4.0, 4.5, 3.9, 3.6. Now significance is 0.01 and 0.05. Now in this situation, we state our null hypothesis and alternative hypothesis. That's our step one. And from the question, our null hypothesis is 3.5. And they said a midwife claims that the weight of babies delivered at a maternity clinic is what? 3.5. That statement has been made. So that will be equals to 3.5. Now for the alternative hypothesis, it will be not equals to 3.5. Step 2, what we are going to do is that we state the level of significance, which is denoted by what? Alpha. So that will be alpha equals to what? 0.01 and 0.05. Remember, I did not just write this figure down, it was given in our question. It says test the midwife's claim at a level of significance of 0.01 and 0.05. The step 3 is that you state the test statistics, that's the nature of sampling distribution, whether it's a t-test or a or whether to use the z-test or the t-test. And in this situation, our population variance is unknown. There is no variance. I'm sorry, our sample variance is unknown. Please don't make that mistake. For t-test, it is sample variance, sample population. Why for z-test, it is population variance, population standard deviation. Okay. So step 3, we're going to use the t-test. Why? Because the population variance, the sample variance is unknown. So that will be our sample mean minus our population mean divided by our standard deviation divided by square root of n. Now from the question, we're given some observations. That's 2.8, 2.5, 3.2, 3.5, and we keep going on. Now in order to find our sample mean, which is this, all we're going to do is summation x over n. Now summation x, that's summation of all the observations that we're given divided by the n, that's the number. So that will be 2.8 plus 2.5 plus 3.2 plus 3.5 plus 3.7 plus 2.7 plus 4.0 plus 4.5 plus 3.9 plus 3.6. Then you divide it by the number. So that'll be, you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'll be 10 divided by 10. When you divide it by 10, when you add everything together and divide it by 10, you get your sample mean as 3.44. Next, you identify your population mean. And from the question, our population mean is equals to what? That's 3.5. Now, next, you get your sample standard deviation. Now, in order to get your sample standard deviation, you have to first of all get your sample variance, then you square your sample variance to get your sample standard deviation. So how do we do that now? Remember the formula I told you. That will be x squared equals to summation x minus the sample mean square divided by n. So that means we're going to use our x, which is 2.8, 2.5, 3.2, 3.5, 3.7, 2.7. We're going to pick them each and minus the sample mean from it. Remember, our sample mean is what? 3.44. Then we square it, then divide it by n minus 1. Remember, degree of freedom. So now let's do that. So that will be x squared equals to, when you do 2.8 minus your standard deviation, your sample mean, which is 3.44, then you square it, you get your answer as 0.4. So in order for us not to waste time, let me just write the figures down. So that will be 0.4096 plus 0.8836 plus 0.0576 plus 9 over 2500 plus, forgive me that I'm not putting this in decimal, plus 0.0676 plus 0.5476 plus 0.3136 plus 1.1236 plus 0.2116 plus 0.0256. And then divide them by the level of freedom. And remember, from the question, our n was 10, is 10. So that will be 10 minus 1. Remember, n is 10, so that will be 10 minus 1. So when you add everything together and divide it by 10 minus 1, which is 9, you get your answer. You get 0.4049. Now this is the answer for your sample variance. But it doesn't stop here. In order to get your sample standard deviation, because that's our focus, that's what we're looking for. In order to get your standard deviation, you are going to square it. You're going to do square root of this. And when you do square root of this, you get your answer to be 0.6363. Now let's impute everything into the t-test formula. Before we do that, let's state it again. Remember, our t-test formula is equals to what? That will be sample mean minus population mean divided by our standard deviation over what? Square root of n. And from the question, from what we've solved, our sample mean is what? 3.44. So you write it down. 3.44. Minus our population mean. Our population mean is what? That's this. So that will be 3.5. Then our sample standard deviation, which we have already solved here, is what? 0.6. When we approximate it, it will be 0.6. Then when you impute this into your calculator, I'm sorry, I'm missing something. Divided by what? Square root of n. And n is what? 10. So that will be square root of 10. So when you solve through, because of time, please impute this in your calculator and get the answer. But what we are going to get is minus 0.06 divided by 0.1897. When you put this in your calculator, you get your answer to be 0 minus 0.3163. Now the next step is to find the absolute value of this test statistics, of this t-test. Remember, for absolute value, when the figure is a negative value. Absolute value is the opposite of it. That will be a positive value. So now we're given a negative value, which is what? Minus 0.3163. So the absolute value for it will be equal to what? 0.3163. Now the next step is that you find your critical value. And note, in order to find your critical value, you need to be sure to get your level of freedom and your level of what? Significance. But first of all, remember, you need to also identify whether it's a 2-day test or 1-day test, which I've already identified. It is a 2-day test. Why? Because from the beginning, which our alternative hypothesis is what? Not equals to, meaning it is non-directional, meaning it is a 2-tailed test. Okay? So first of all, remember what I said. We find our level of freedom. And our level of freedom is what? N minus 1. That's 10 minus 1 to give you what? 9. Then our level of significance. Now, in this question, we're given 2 levels of significance. That means we're going to find for the first level of significance, which is 0.01, and the second level of significance, which is 0.05. So now, I'm going to solve them differently. When our level of significance is denoted by alpha sign, is equal to 0.01, our critical value remember, I told you that we're going to do 0.01. We're going to do 9 under 0.01. But this time around, it will not be under the 1-tail test. It will be under the 2-tail test on your T table. Please take notes. Because on your T table, you will see 1 sample, 2 sample. So you follow the 2 sample way, because in this question, we identify that it is a 2 sample. It is in a situation whereby we are meant to use a what? 2-tail sample. So you look for 9 under 0.01 in your 2-tail sample and your 2-tail test on your table. So when we do that, our critical value will be equal to 3.250. Now, when we're not going to find for the other level of significance, when your level of significance is equal to 0.05, our critical value will be what? Please try to solve it. Well, if the process you took is identify your level of freedom, which is already 9, and finding 9 under 0.05 under the 2-tail tests on your table, then you are right. So you are going to get your critical value to be 2.262. Now, the last step, which is our step 6, we are going to identify whether to accept or reject it. Now, for the first one, whereby we got our critical value at for the first one whereby we got our levels when our level of significance was 0.01, and the critical value we got 3.250. Okay, then for the second one, which was when our level of significance is 0.05, and our critical value is 2.262. Now remember, in order to take your decision, you compare your critical value with your with your test statistics, which is your Z test or T test. But in this situation, we compare it with our T test. That's our calculated value. So from our calculated value, what do we get? Let's look back. Our calculated value, we got our answer to be 0.3163. So you write that down. You also put down for the second one so that we can compare them together. Now for this first one, when our level of significance is equal to 0.01, we can see that the critical value is higher than the calculated value. So we what? Accept the null hypothesis. For the second one, when our level of significance is 0.05, we can also see that the critical value is greater than the calculated value. So we also accept it. So our conclusion will be that at 0.05 level of significance and 0.01 level of significance, we accept the null hypothesis. Thank you.